Now, a traveler from deep space has fired up some clean controversy once more. New thermal gradient photos of Interstellar Item 3 Atlas have revealed jets that look shockingly prepared. And the scientists are asking, is this natural physics or is there something far stranger? In recent months, astronomers around the world have watched a phenomenon unfold that challenges a number of the most important assumptions in comet science. The Interstellar Object 3 Atlas has begun displaying behaviors no comet on record has ever exhibited. Every new observation adds another layer of confusion, fascination, and scientific tension. And now, with the release of new thermal gradient heat maps and amateur astrophotography revealing a rapidly expanding coma, the puzzle has deepened in ways few expected. From the moment 3 Atlas entered the observational range, researchers noticed something unusual. Comets normally lose material under solar heating, ejecting dust and gas in chaotic plumes that form a tail pointing away from the sun. But 3 Atlas refused to cooperate with this script. Instead of shedding visible debris, it moved with uncanny steadiness, clean surface, stable rotation, no wild tumbling, no fragmentation, and no dust-filled tail streaming behind it. In an era defined by precision space instrumentation, anomalies are rare. Sustained anomalies are almost unheard of. And yet, 3 Atlas quietly insisted on being one. The first major shock arrived when a new imaging technique, thermal gradient imaging, was applied to the object. This method, able to detect subtle temperature variations across fast-moving bodies, produced results so precise and structured that many researchers initially suspected instrument error. Yet repeat scans confirmed the truth. 3 Atlas was releasing slim, pulsed jets in consistent, evenly spaced patterns. Typical comets produce chaotic outgassing irregular in timing, direction, and intensity. But 3 Atlas's jets ran like a metronome. Their spacing and directionality echoed the signature of controlled output rather than geological chance. Scientists, careful in their language, stopped short of implying intent. Still, the phrasing in many early reports reflected quiet astonishment. Terms like smooth, directional, and organized slipped into discussions normally reserved for spacecraft telemetry, not comet physics. Natural explanations are still possible, such as subsurface volatiles venting through unusually narrow channels, but the predictability of the patterns seems to strain traditional physics. 3 Atlas exhibits neither the chaotic personality nor the dramatic instability expected of cometary jets. Instead, it appears to behave with a deliberateness nature almost never displays. Then came the images that further disrupted expectations. On December 2nd, amateur astrophotographers captured extraordinarily strong, symmetric frames of 3 Atlas that quickly circulated through astronomy forums and social channels. These new photos showed a coma expanding outward from the object, but with a trait that defies the behavior of nearly every comet ever observed. Symmetry? No directional tail. No sweeping arc carved by solar wind. Instead, the coma glowed with smooth brightness gradients as though wrapped evenly around the nucleus. In one processed frame, the central point shone sharply, while the surrounding glow thickened uniformly, suggesting rising density without directional distortion. Professional astronomers warned that amateur images can be prone to processing artifacts. Yet the symmetry persisted across multiple independent captures. Combined with 3 Atlas's known tendency to resist solar wind shaping, the absence of a tail became more than unusual. It became physically difficult to justify. Solar radiation pressure should strip dust and gas into a tail. Yet 3 Atlas retained a round halo seemingly resistant to external forces. Adding further intrigue was a feature that emerged in post-perigee observations, a faint but persistent elongation pointing toward the sun, the opposite direction in which a comet's tail should form. This sunward antitail quickly became one of the most scrutinized aspects of 3 Atlas because such a structure suggests that material associated with the object is behaving in ways not anticipated by standard comet outgassing physics. In traditional scenarios, solar radiation pressure pushes dust and gas away from the sun, forming the familiar tail. But in the case of 3 Atlas, the elongation remained oriented sunward across multiple observations. Harvard astrophysicist Avi Loeb proposed that the feature might not be a classical dust plume at all, but instead the optical signature of a sizable swarm of small bodies, potentially billions or trillions of fragments trailing behind the primary nucleus. According to this interpretation, 3 Atlas could be experiencing slight non-gravitational acceleration by virtue of its structured microjets. If the nucleus accelerates even subtly, unpowered fragments around it would fall behind and, depending on geometry, appear toward the Sun from Earth's perspective, since a swarm with extremely high collective surface area would reflect much more sunlight than the nucleus itself. This could explain the bright symmetric glow now frequently observed around 3 Atlas. Though mathematically coherent, the hypothesis remains controversial. Researchers emphasize that invoking a swarm of objects to explain observational behavior is unprecedented, and several alternative models offer less extraordinary explanations. One natural mechanism involves sublimating ice grains. Under certain thermal conditions, micron-scale particles released from the nucleus can survive long enough to form a sunward spike before radiation pressure disperses them.